Okay, great morning to one and all, prospective students, faculties, parents, my dear friends and my colleagues, all very warm welcome and great morning to you all. Um, I'm Dilip Kumar, currently working as civil engineering professor at Mahindra University. And then me and my colleague Praful have started this Center for Sustainable Infrastructure Systems, and we are doing a lot of work. Some of the work which has been done at our center is also being showcased in a couple of slides, 1 or 2 slides. So in fact, this is a passion for me from a long time to know the journey of civil engineering, how it has started and how it is going right now, and how it will intend to go in coming few days or maybe in for few centuries. So keeping all the mind, from very beginning of civil engineering, started to see one of the most widely accepted engineering field, and these days slightly down in students' mind. So taking up civil engineering in their undergraduate or their masters. So what happened to civil engineering? How did it evolve, and why did it become a little weak, even though we really need civil engineering, even though it's very vital in building the society? So what actually has happened, and what is missing? That is what I'm actually trying to discuss today. In fact, how will it evolve as one of the best streams in coming few years? That is what is all about the seminar. Okay, the outline of this presentation would be, I'll talk about little background, because when we talk about journey, it is important that we have to start exactly where it has started, the journey where it has started, and how it is today, and where does it go. So I'll talk about little background, and then in background, of course, I talk a little civil engineering, civilizations, and then where did it all go? And then I'll talk about the current civil engineering. Even though I have just kept these 5 elements of nature, I would largely speak about different fields in civil engineering and how they are actually doing these days. And then I'll talk about what is the problem of the current engineering. Why it happened and why is the problem? Even though we have the best solutions today, what is that which is making us weak in and around us, especially from the point of civil engineering? And then finally, I'll talk about little 1 or 2 case studies. That's exactly what are we up to here at Mahindra University, and what kind of research are we actually started, and where are we trying to plan to take up. So this is the outline of my research, outline of today's presentation. So coming to the presentation, coming to the background, civil engineering has been evolving exactly like the image you see. And then suddenly it's getting into computer science. So what has been change in era? So it all started from the early mans, where people have started moving from place to place to get their food, and which is called nomadic life. And suddenly they started to live in caves wherever there's a natural formation of houses. But then over the period of time, they started to stop the nomadic life and to stick one place. That's where the civil engineering has come into the picture. The earliest practice of civil engineering may be commenced between 4000 and 2000 BC in ancient Egypt, which is exactly more than 6000 years from now. And then there were certain civilizations like Egypt, Indus, and Mesopotamia, where these people have abandoned nomadic life and started settling down, and that's where they started even building their communities as well. So that's where the whole civil engineering has started, when they started to build something for their life. The history of civil engineering is a mirror of history of human beings on this earth. Exactly, the engineering says how the human beings have evolved over the period of time. So this is couple of engineering which has been used around thousands of years back. So this is called Kanat water management system, Kanat, and this is seen in Persian, Iran, Iraq, where there is a scarcity of water, and then they have dug a tunnel exactly horizontally as you see in the image, And then they have these wells vertically down. So horizontal tunnel which has water in it, and vertical wells they use those wells for removing water. This is used way back 3000 years back. And this Connect water management system is, the length of Connect water management system is approximately 70 kilometers in length, maybe more than that. This is not only one place where they have found this system, but they have found it a couple of other places as well. So this was one of the most water system which they have found and used. Right now we don't use that. And then Parthenon, it's in ancient Greece. What we see is columns and beams and architecture and mammoth. All this make a huge structure, and then the locking mechanism and everything. This talks about simple physics, and then gravity, and then the designs and stability of the structure. And largely that has been used and seen in Greece, the mammoth structures. And then this is coming to the 312 BC. Roman engineers also used pathways like this is the stone blocks which were laid for a pathway, and these stone blocks of pathway are even seen today, which can see the longer life. And like in Indus civilization, it is said to be one of the first civilization which they have seen brick pathway. Like that, Roman civil engineers have this rock pathway. They had longer durability in age, especially the stone structures. And then a great wall of China, which is 220 BC. This is one of the longest wall brick with stones. And of course, they also used lime and gypsum as a binding material between the walls. If you can see the clear picture, at the bottom part, we can see the binding material, which is not cement, but it is like a cement, like gypsum and gypsum and lime, which is of very natural. So coming to the Sri Lanka, this is one of the largest and tallest stupa. Even till today, this is the largest area in stupa, which is also built by only bricks, mud burnt bricks. This is actually, it was 122 meters, but it was destroyed. And now after restoring it, the stupa stands for 71 meters in height. This is seen in Sri Lanka, and which was built in 272 301 AD. And then this is a aqueduct. So aqueducts for the water control, either from the oceans or rivers, they have used aqueduct in the Roman civilization Caesar era. So what exactly I am trying to tell you is how this engineering has developed in building mammoth structures, and how did they actually use water systems. These were largely two things which were discussed in past few slides, and this picture actually talks about Machu Picchu in Peru, which is built in 1450. This talks about the society, development of a society at the topmost on a hill. It said this is Inca Empire. This is also built in Andes Mountains. And then one of the best part of this society building and this civilization was it has indigenous water sources. So water was used, and they had perennial water all over the year, even though they were on the top. One of the best part. So they did had one of the best systems in building the houses and their kingdom with stones and other natural materials. They have also used wood. And second thing, they had the best water management system. And in this Machu Picchu, they have also seen, apart from drinking water, they have also seen the sewage line, which actually says that they have also understood to treat the waste which has been released by the society. This is building of society. So these two pictures shows us how the basement and how the top part of the stones are used to build structures. And then of course we also classify these ages into bronze and silver. If we see the clear picture, if we see the picture in this slide, then they actually talk about very natural materials which are used for construction. At some places you can see the first picture actually shows the dry grass and mud which was used for construction on the top left, and mid actually shows the leaves and wood for construction, and right corner is a little advanced treated wood and a little glass. And then bottom part actually shows the houses built with mud and complete wood and stones. All these are based on, especially on local materials, which are largely today called as sustainable material, and they nevertheless they don't release any kind of pollution either in terms of air, water, or earthen. So these are three pollutions which we actually check even today. So there is no air pollution, there is no water pollution either, there is no earthen pollution for this. This is based on age, Bronze Age solution. And then we have Mayan, Egypt, and Roman civilizations. You can see the Egyptian pyramids, one of the uh, most stablest structures in geometry and all that you can see in Mayan civilization, and then Roman civilization. What can be seen or observed in this slide is the designs are very unique in their own way. Few are pyramidal in shape, circular in shape, then tapered in shape. So they all are very different in their nature, which actually says that geographically, these civilizations have evolved based on their local environment, geographical reasons, and then also natural materials, which actually has given an evolution of geometries. And all these geometries actually withstood any other natural calamities like earthquakes, floods, and anything, apart from human disasters like war. And then there's a skill. We can see very precise skill of religious places like temples. So we can see stones are placed in locking mechanism, and we can also see the temples built with one stone. And there are various kinds of structures which were built, which actually shown a marvelous skill in their engineering. And this geometry is not just evolved like that, but this geometry also speaks about the stability of these structures. As we see, the shape decreases or tapered when it goes top, and this is can withstand flood or as well as even wind and also earthquake. So these structures had geometry and then stability and resistant towards other natural disasters as well. And then castles which were also built with stone. Now, all this has gone between few centuries. Now, for most of us, the history is still a secret. History is still a secret, and we are still trying to see what is the mystery behind a lot of historical structures. Then it's not exactly a secret, but it's open secret. Most of people know that there was a contradiction between a religion and science, and then people were executed, and then the secrets were kept in another form. If you can see this picture, this is from the Telugu movie Arundhati, even though this is a fictional, but this is a fact from the history that even though this image portrays something, this image consists of certain information. Exactly similar to this, history also speaks about Leonardo da Vinci. This is a Mona Lisa. This is one of the most costliest portrait in the world. Does not only speak about laughing or crying or emotion, but people believe that this image has got some inherent knowledge or some hidden treasure in it. So when there was a difference between science and religion, all the information was kept in the form of a portrait. Largely, this were built with mechanics, also treasure of something. So when I read about history of mechanics, then I did read about Leonardo da Vinci. He has portrayed certain images consisting of simple mechanics of constructing very large mammoth structures. Continuation to this, in short, ancient civil engineering structures largely talked about natural materials like stone, grass, wood, any other material. And then they also speak about, this is Chandni system in India, which talks about stepped water system, and they say that there is never a dry of this water, even though this is built in desert. This is water systems, which actually says that they had absolute understanding of nature. And then they talk about art and engineering, and this actually shows their integrity and commitment to the work, which actually talks about skill and also speaks about the stability of structures. Of course, I didn't it also talked about transportation. They largely used natural materials for transportation, and which are also durable even till today. And then they had the building of society building with the natural materials. This is one of them is Albang. This is in Iran, and this is largely built with mud, and that's the only the biggest and largest mud society in the world. And because of one earthquake, it has been destroyed, demolished a little, but then it has been completely restored by 2016. And then the last one is all these structures show some kind of culture or tradition in it. So this is what ancient civil engineering, if you can see that all these actually talk about the even modern civil engineering as well. So the current civil engineering, which I said I'll talk about, even though this is all about space, is how to utilize space. Air is all about how do you take care of wind forces, or how do you is designed for wind circulation, or wind circulation. Fire is nothing but heat control in the structures, and water, and then earth. So modern civil engineering, if anybody would type it in a Google, then we have a simple definition. It's called, in modern usage, civil engineering is a broad field of engineering that deals with planning, construction, and maintenance. These three are very important. It comes with planning, construction, and maintenance of fixed structures or public works, which are largely government structures, as they are related to earth, water, or civilization and their process. So it actually talks about planning, construction, maintenance, and all about five elements, how they are integrated to come up with fixed or public structures. So civil engineers are always working in shaping the world as we live today. The whole world structure is actually designed by architects and civil engineers, and that's what is largely believed. And right now, this is changing a little. Example includes building roads, railways, bridges, canals, scrappers, factories, all etc. So these days, modern civil engineering is also focusing on aesthetic and environmental impact. That's where the term comes, or that where the terms come something called sustainability engineering in it. And civil engineering today, we have multiple fields, like we have a construction technology or construction management we have, and then environmental engineering, environmental sciences, and then geotechnical or soil mechanics, and then material is one of the foremost, very important in civil engineering. And then we have structural, and then spatial informatics, which have changed the scenario in last few decades. Transportation, one of the most important problem in the past, today, and also we think that it will be in future, but we have solution to this. Urban planning is still a challenge for many cities all around the world. Even the developed countries are also facing the urban planning problem. And water resources is really another big problem all over the world. That's why we have greenhouse gases effect, and then people are getting aware of scarcity of water and what could be the future water. So construction, if anybody is if you are actually traveling from Hyderabad airport into the city via outer ring road, you can see number of cranes, vertical cranes working on multi-storied structures, where the heights of structures are ranging from 15 story to almost 40 to 50 storage structures. So when we drive, we can see a lot of structures. At least hundreds of cranes are working in along that road in building all these tall structures. So these cranes have actually changed the fate of the skyline of the city itself. So that has made work easier and faster. This is the crane. Second, this is construction China. This was very similar, which was also used in L&T Hyderabad for moving up a girder from one pier into another pier. So you can see the movement of girder with use of a huge mechanical equipment vehicle. So this has made construction of bridges much easier. It works in a cantilever concept, if you have known a cantilever in civil engineering. But then this makes work faster. Unlike like previously, we use a lot of scaffolding and shuttering. Anyway, shuttering is used for this one. So a lot of groundwork can be avoided with this larger equipment. But then it has to be done very carefully, because one single accident can have a huge disaster. And then this is one of the Millau Bridge in France. Uh, this is can restrict with very harsh environments. One of the reason why I included this bridge is modern days bridges. This is one of the tallest bridge, and then this material is so high. They have used lots of tons of steel and concrete that this is actually resisting towards extreme weathers of snow and also high temperatures as well. One of the tallest bridge which is seen in France. This is in continuation to this is Chenab Bridge. Now India Northern Railway is actually building. In fact, this is almost done bridge, world's highest rail bridge by Indian Railways to connect Kashmir to rest of India by 2021. This is very recently when we have attended the seminar on National Academy of Construction. They said the bridge is almost done. So it will actually decreases almost this bridge actually decreases the transportation in 300 by 326 kilometers of journey, and the length of the total bridge is 1.3 kilometers. This is tallest, and height is 359 meters. And if you talk about a material, it's using 25,000 metric ton in steel. That's really huge, and it has to withstand a wind velocity of 220 kilometers per hour. Hyderabad, when it had 150 kilometers per hour, then we had a lot of billboards, advertisement boards failure in Hyderabad. We think about 220 kilometers per hour is very, very high. Of course, there's a speed limit which actually allows 100 kilometers per hour, even though it is designed for 120 to 140 kilometers per hour. So this is Chenab Bridge. And then when we compare it to the Eiffel Tower, which is one of the tallest steel tower in the world, that is 324 meters, but this bridge actually stands at 359 meters, making it one of the tallest bridge in the world. And then this is during the construction. They had literally a lot of challenge while constructing. It was not an easy task, but then this is almost done bridge. And then environmental engineering or environmental sciences. Even though we have developed in multiple fields and multiple dimensions of engineering and sciences, we still face one of the biggest problem is environmental pollution. Right now, I would like to limit my presentation only to the civil engineering perspective. So there is one article in Guardian in last year which says concrete, the most destructive material on earth. Even though there was a previous article in 2017 that concrete the most versatile and usable for construction. In 2019, this has actually become a destructive material. Why is that? Which has happened? We all know any material which is used for a limit purpose, certain limit, that is absolutely fine, like plastic. Once it starts crossing the threshold, it causes a lot of environmental pollution. Now concrete has become that. Concrete industry and usage of concrete has been releasing a lot of carbon dioxide into the global environmental pollution, which has made a very big issue into considering. Of course, people are coming with solutions of like green structures or green buildings. Of course, I would like to talk about in the last slide of this presentation where I'll talk about green buildings or advanced buildings. So environmental engineering is one. Environment does not only actually restrict itself to air, but it actually also consists of earth, water, and also sound pollution as well. But then all these are actually read in today's engineering. Geotechnical, we have been much forward in geotechnical engineering. We are able to have the longest, biggest, largest diameter tunnels anywhere in the world with tunnel boring machines, TBMs, where we are able to make tunnel of a kilometer in a day. And that's how the revolution has been. And then with diamond cutters, the things are much faster. Simultaneously, we can cut the tunnel and we can also make the concrete lining on the tunnel, so making it one of the much faster tunneling systems in the world. So these are this is one of the tunnel which is being laid in Jammu and Kashmir, which is connecting Leh and Srinagar, and then this is about to open in 2022. Anyway, things have started to move, and technology, whatever current engineering practices are there, they have made civil engineering works much faster, precise, and a little more robust. And then this is soil stability. Even though it looks like a very small place, but then slope failures have become one of the bigger problems, especially on the hilly terrains. you talk about India, then it's northern part or northeastern part of India have slope failures. In fact, there were slope failures 2 days back because of the floods. So the floods actually weaken the soil and they have slope failures, and this was following in Meghalaya near the Shillong region. Of course, there were no fatalities, but then it is assumed one of the large landslides and slopes which has been occurred after a few years. And then these slopes with the current technology, with the fiber and geosynthetics, they are converting these slopes into greenery by providing this hexagon shaped synthetics and then having the grass on it. So Geotechnical has also gone a lot farther in this area. Water resources, for me, water resources is where we can get water. How do we store this water and how do we use this water? So water resources are fluid mechanics, everything we actually try to understand about how do we get water, how are we using water effectively, and are we actually trying to treat water? So one of the biggest disadvantage of today's water is treatment of water is not even 20% of whatever we are leaving as a waste. So 80% of the water is not being treated, so making it harmful to the nature. So water resources and environmental engineering combinedly with fluid mechanics combinedly are working on available resources, effective use of water, and then this whatever right side bottom image you are actually seeing is the treatment plant of water. One we have near Tangband. And then spatial informatics, this is also we are improving. And then once the spatial informatics has come into the picture of civil engineering, a lot of things have changed. Now we see city in terms of layers. So you can see this, you can see as a vector raster where you see the real world, and then you have different layers showing how much is the land usage, what is the elevation, and what are the different parcels and different streets, and where the people are, how is the public distributed on this land. Everything is understood in terms of layers for the same place, helping us to design an urban much effectively at same point of time. This is spatial informatics. Apart from that, this is also helping in today's caps. I know GPS, it uses the global positioning system, uses the cap position. It'll exactly give you the time of reach from your starting point to your destination. This is spatial informatics in engineering. And transportation, of course, in transportation all around the world, we've been very successful in building one of the broadest roads world has ever seen, and we were also very successful in building one of the most complicated interchanges in the world. This is Singapore interchange. Similarly, there are a lot of interchanges all around the world. Very few, like Hong Kong, Japan, and Singapore, and Mumbai, all these places have complicated interchanges. But then of course symbols and signals, they help us in reaching the destination, but when a miss, it takes kilometers of road. So but then yes, we have the big transport system. Urban planning, this is Barcelona's car-free superblocks, where there are series of houses. You can see this is one of the most urban planning is how we are replanning the growth and control of cities. Is still a challenge these days. This is called greater communities. This is one of the picture which is taken from the Hyderabad. Greater communities are those societies where we have some 3,000 to capacity of a 25,000. Even we have a bigger communities of 1 lakh, where we are actually trying to manage everything inside the community. So smaller communities, better the management with this tag. Communities are trying to build these greater communities, so for better management. But still we have certain things. This is the left side. What you see is how do we manage water in these communities, or how do we manage this water in the growing cities? That's still a big challenge for us. And then what is lacking? Of course, this picture is only to small awareness, and I'll add answers to these pictures. Uh, Even though we have the broader roads, still there's a bigger problem of traffic congestion. We have the best education system, but yet we have the traffic congestion system. Why is this? Is the question mark. And then it makes even worse when we have floods. In fact, 2 days back or the next day, yesterday's, day before yesterday's, we can see there are a lot of floods all over the India. And then even the pandemic, there's a still lot of congestion on the roads. This makes really a disaster. Uh, uh, Even it's not only in developing countries, it is also in developed countries. You can see how the traffic is being managed. This is, you won't see any systematic in this traffic. It's going to take hours, even though morning till evening, until this traffic congestion gets cleared up. So there's still a problem in it. Even though modernly we have all kinds of engineering, best of technology, we still lack these things. Now this is a very big U-turn. You can see this in the right side picture. You can see how much time, you can just guess how much time it's going to take when all these vehicles move up a U-turn and the other lane which is coming in the straight. So these things are still promising for the current civil engineers. This is, I said cultural and traditional. This is yesterday. This is in China, one of the religious structure. I said this was built way back. Now there's a flood in it. Still we are not able to predict the flood and its height, and we're still poor in managing the floods. And then this is in India. Of course, this is also taken a couple of days back. Still we have a problem in disaster management. And then of course, one of the biggest problem the country and the most of the countries are facing is the plastic and sewer. So they are both are inseparable. And then this is one of the biggest challenge right now most of the countries have, especially the developing countries. And then there's a contrast between the contrast. This is in one of the biggest slums in Asia. This is Mumbai, and then we see the different contrast of buildings and of apartments, and then brick houses or metal houses. Now, with all this, I said about ancient, which has got been talking about natural materials, sustainable materials, water systems, sewage cleanings, and everything. And suddenly everything has gone because of there are wars, and the knowledge has been gone. And then we are trying to build all the knowledge, and then we did build. Then suddenly we still face a lot of problems. The question is, where are we going, and what is this really lacking, and how do we get rid of all this? So this has come up with a lot of solutions. You know, in summer it's really hot in our houses, and then we are using cement, and cement makes buildings much more hotter. So how do we solve all these problems? Now this is where we started. Civil engineering right now, it has taken a very big revolution, and then technology is really adding for that revolution in a very big way. Civil engineering right now is not independent by itself. It has been added by a lot of other tastes to change into a different uh, shape. Largely civil engineering is known to have a cap, papers, pencils, and drafting, a lot of these things. But then civil engineering, all these are all removed. These are removed and then replaced with something called building information model. Even though like 17% of the world right now using building information model, this actually helps in digitizing the complete building from the scratch to the complete maintenance of the structure. Very good improvement, very good addition to the civil engineering. Right now, construction management, anyone who does a specialization in construction management in the advanced colleges, then building information model is one thing which students take it and they are part of it. Very developed countries like Singapore and all, they are actually Japan, Singapore, USA, European countries, including a couple of buildings in India, have been using building information model, and they have seen that usage of this actually has reduced a lot of miscommunications between different parts or different parties in the construction. Like you can see, building information model is a turning point in the route of digitizing the construction industry. It's one of the most promising advancement in the architecture, construction, and engineering industry. It's a tool to create more transparency and benchmarking in the sector, which has actually evolved. So what does it do? It does the coordination between different parties, so that what is lacking in another. So like architecture, civil engineering, and the plumber and the electrician and interior designer and the owner, everyone is involved in this, and they can see what is really happening at every point of the structure. and immediately we can know the drawbacks. We can also know why the work has been stopped, and we can see the virtual simulation, and then we can see the how it looks when we have interior design, everything. So this is a new generation, and then this is building information model, civil engineering with computer science. Burj Khalifa is one of the nascent examples, which has used complete building information model for its construction. And then it also used wind calculations for even this Burj Khalifa. Everything is been building information model has been used for Burj Khalifa. Right now, it has got number of sensors, and due to wind or earthquake, it will give us the alarm. So everything is digitized of Burj Khalifa. And with mobile or a system, we can control a lot of things in that structure. Again, it connects computer science, electronics, mechanical, and civil engineering. Now, once that is digitized, I know a lot of students these days, especially in last 4 to 5 years, with the development of phones, we are able to switch in, switch off the fans, heaters, motor, TV, air conditions, and everything. This is smart home. With advent of computer science and with a good knowledge of programming, the whole structure can be converted into a smart home, where everything is controlled by the simple one gadget called your laptop, or this is a cell phone. In fact, in our college, I have seen a couple of students actually use the cell phones for switching on, switching off the AC and projectors. That's a very good thing when we actually miss the actual remote of those instruments. So smart home is again trying to make things effectively in terms of light, energy, and wind, and everything is making optimized using smart homes. Of course, apart from its security. And then another big thing which is coming up into the industry where is called modular construction. Of course, I would like to keep in a small terms. Anything like modular furniture, right now civil engineering has gotten to modular construction. Even the biggest of the biggest bridges around the world are using modular construction, because it makes construction much faster, work is precise because everything is machine made, and things are little robust when compared to the manual construction. Of course, they have its own smaller limitation, because transportation one place to another place is a challenge, but that has been addressed because these panels can also made in a small scale and grid, and they can be rearranged at the site. And they have seen the quality is exactly like in situ. This is plastic. As I said, one of the biggest problem right now we face all in the world is the plastic. So this is the plastic. Right now in Hyderabad, I would like to take up one small example in Hyderabad itself in 2018, 2019. This is, we had this person in our own campus whose name is Prashant Lingam, who is being taken a very big initiative in our country in converting the plastic into tiles and construction material. So this was inaugurated in Gachibowli in 2018, and if you can see, 950 plastic bags actually made one tile. So to everything of plastic can be converted into a construction material, and we need construction durability of 100 years. So all the plastic which is currently available, or which is been just thrown at the sewer lines or at the waste, is currently being segregated. All we have one problem is segregation of this plastic, and once it is segregated, this is compressed at a high temperature, and converted into a construction material. This is another new dimension of civil engineering, where we convert the whole waste into construction material in decreasing environmental pollution. And then drones. We are also using currently drones for building inspection. So we are also using this for structural health assessment. Drones are used for structural health assessment as well as inspection during its construction. And then AI, artificial intelligence. I was very lucky to have one of my colleague, Ms. Profula, who has been helping us in understanding AI in assessment and these things. So we're also trying to use AI for railways, where a camera will be fitted to the railway engine, and it can detect the possible defects in railway lines in future railway lines. So this is in the process of development. So this AI which you are trying to see, it tells number of persons who are working and what a person is also working. and based on color of their jackets, it tell how many engineers were there, how many laborers were there, and how many professional, how many construction management. Everything can be distinguished. So carpenters, plumbers, engineers, laborers, everything can be distinguished easily with the help of drone and AI, or with any other camera which is fitted into the structure. This is another new engineering and construction management for making things effectively. So this is an innovation. This is a 3D building. Gia has built a 3D building with using mud. And this is one of the first 3D building which was completely built with mud. And then the whole world right now is moving into materials, so that that material can be used into this construction for building these structures. So even in Mahindra University, Shiva, one of the mechanical and civil engineers, have combined together as a team, and they have also started to build a modular or a 3D structure for economic sake. So this is the picture of the actually completed 3D building in Gia. And then now this is bottom picture actually also shows the 3D printed building, another 3D, a very well finished building. And then now if this has been developed, then this can also help in building row houses. So it can actually eliminate slums in any country, especially like our country. We need a modular and 3D printing which can build houses, and we can change the scenario of one single slum over a days of time, not in years of time, but in just days of time. Maybe in couple of a week we can change the whole scenario of a slum area. Hope students can take up this engineering and then can change the fate of the country. And then our vertical villages, the answer to an eco future. Since cities are rapidly developing horizontally, engineers and architects have come up as a team up with environmental engineers in building the vertical villages. These are actually inspired from nature itself, ant houses or something like that. So these are completely green, like cyber towers. If you see this image, actually depicts a cyber building in Hyderabad. Even though that is a single, this has got multiple levels of the same structure, which actually has complete internal water system, and then it can also take care of temperature. These structures can also take care of light. This can also treat their own sewage within the same system. This is a new engineering which is going to come up in next couple of years, in fact within a decade for sure. So this is what I said, green buildings and green society, like greater communities, like we are gonna get this green cities or green towns or green smart cities, smart villages, where we'll have complete greenery vertically. Everything is taken care within that system. This is another solution for pollution. And then architecture and nature, for structural stability. These structures are actually inspired from nature, like honeycomb. This is also used in Olympics. A lot of stadiums have been used in China as well as in Brazil, Rio, where structures are actually inspired from nature and designed and constructed. Like even now, which is in Saudi, where Olympics are going to be conducted. So these structures are inspired from nature. One good thing about this one is, I'll tell you about this one is, this is a structure which can actually take the humidity, convert the water, and do the internal plantation or internal farming. So this is one which is completely inspired from nature, is house farming. Right now we have terrace gardens and all. House farming is one good thing which is into the next generation to come up with. This will be in part of civil engineering as an agricultural engineering. And of course there are various shapes which can restrict all natural disasters. So those geometrical shapes are actually designed from nature, from animals and plants. This is biomimic engineering, which is specialized part of civil engineering. And self-healing concrete, as I said, concrete is one of the most major material which has been used all around the world, and large quantities into construction. And the fact is that it cracks, and cracks are seen everywhere. So scientists have come up with bacteria, and they have also come up with the water solution which can actually reacts and then it produces lime and calcium carbonate in filling these gaps. So this is before and after. You can see the lime formation within the crack, making it healing by itself. This is repairable pavements. So self-repair pavements or self-repair walls. This is between chemistry and civil engineering. Chemistry and civil engineering. When chemistry and civil engineering are excellent, then we have such kind of products called self-healing concrete. This was one of the BTech project which we've been doing in Mahindra University as well. This is structural health monitoring. Right now we are very active in this. And then even though this is into visual inspection, NDT, vibration, and data interpretation. Visual and NDT, visual is largely about civil engineering expertise. NDT is largely civil and mechanical. Vibration is electronics, mechanics, and civil engineering. Data interpretation is computer science. I wantedly have kept this picture because this consists of all the engineering into civil engineering to make structures to feel live. So all the bridges are being done with NDT testing and vibration sensors, and then a lot of AI is used in interpreting this data and telling the health of the structures. So this is advanced physics, like our professor Dean Academics is working on with photonics. And then this is something called fiber optic sensors. Fiber optic sensors are advanced way of seeing structural health, and these are also helping us to understand the traffic phenomena in the urban cities. And then we are trying to understand how the traffic is distributed, when is the maximum, when is the minimum, and how can we actually plan for the future. These things are really helping in making intelligent transport system as well. So this is fully automated, and they can actually tell us where is the damage in the structure. And this is the fastest way, and we can avoid a lot of structural failures, especially during the floods. We can see that a lot of structural failures, wall collapse, bridge collapse, building collapse, a lot of things. But then these things make a house smarter, and they also make the house lively. We can call that building is actually living because of these sensors. And this is intelligent transport system smart. Right now all we are able to do is we can get the GPS data, and we can see how much time it takes from going from one place to another place. But then in future you can also able to talk with your neighboring car or neighboring vehicle. You can actually talk and say, you can request him whatever it says. This make the system smarter. And then sensors will actually calculate automatically if two vehicles are going to collide or not, and they say to the driver that if this is the speed, then you will have a collision at 100 meters or 50 meters. They are going to predict that. So this is advanced intelligent transport system which is going to come up, and then which will also help in reducing number of accidents all over the year, especially in developing countries. And also it will also reduce traffic congestion, as it also speaks, and you can also communicate with neighboring vehicles. And then you can always have an auto system which can take decision by itself for optimized traffic conditions all around the world. This is already has been developed, a prototype has been developed, and this is being used in several at few locations in the world. And then of course I won't take much time. It's already 11:48, so let me close with couple of 2 or 3 slides. We've been working on structural health monitoring, like cracks. I said I'll have only 2 slides on this. This is one thing. Our own building had couple of cracks, so we were actually trying to take image with the cell phone. This is a simple wall crack, a very small wall crack, and then we were actually trying to take with the camera, and then we were trying to understand the length and width. This is done by UG students with the guidance of my own colleague Professor Profila, using image processing. In continuation that, we have an external student, Narsimha, who is working on artificial intelligence. Sushmita and Kirti, our own BTech third year students who did their internship in Korea, are actually working on advanced technology in detecting crack using AI for structures. In fact, it is not only a crack detection. Since we've been visiting a lot of sites for structural health assessment, we have collected huge data, and then all those structures had deterioration of cracks and spalling and other things. Now AI has become a tool in saying whether the structure is healthy or not. All we have to do is send a drone, it takes the images, or we have to just feed the images, and then our system will tell the structural health. This is what we've been doing in last 2020 summer as well. And then I have started my journey with the ancient. I would like to end my presentation with also with ancient, ancient culture. One of the most mysterious things right now in India are very difficult to tell is what are the different types of foundations of these ancient structures. Then we did use sensors, and then we actually had developed a prototype of ancient sandbox technology, and we have said that this could be the sandbox technology which has been used for Ramappa temple, which has withstood floods and also earthquakes in 1957. So this is an article which was published in Indian Express, where it says about our research. And then there's a huge team, as I said, computer science faculty, Professor Prafulla, Professor Bhargav, and also we also have Professor Prasad, who were also helping in making this project, apart from our own BTech final year students at that point of time. So what what I was trying to say in this seminar was uh, a lot of engineering and science has been developed in ancient, and right now in modern days we have got technology, which is an added advantage. Now what with the technology and the science and engineering, what we are trying to do right now with the next future generation is technology like artificial intelligence, machine learning, image data analytics, and coding and sensors are trying to add into civil engineering in making more robust solutions for all the defects we see today in the society. I said pollution, whether it is a plastic or a water pollution, whether it is a traffic congestion, whether it is a structural failures, or it is a water problem, or it's a soil problem. All these are being connected right now into one big system of artificial intelligence or sensors, and then we are able to solve those problems. So next, future civil engineering is going to be very much interesting, because it's not a pure civil engineering. This civil engineering is going to be combination of engineerings to provide a very comfortable society for the future generations. So with this, I would like to tell that our journey into next civil engineering has just begun, and then it's going to be one of the most interesting engineerings of ever one has ever imagined. All the fields are actually trying to help civil engineering to evolve in having one of the best societies in the world. So I would like to stop here. Thank you once again. Very much. So if you have any queries, of course, you can always post in the questionnaires. I will take certain questions before I end my session. So thank you once again for patience listening. And just before closing this presentation, I would like to tell one thing, that whatever presentation I have been doing, this was our journey, and there's a lot of contribution by our own team, where I said again, Miss Prafulla from computer science is adding a lot of knowledge into civil engineering, and we've been working on it. She was very much advantage, especially she's been working on artificial intelligence in predicting earthquakes too. The first, and we have our own researchers like Sayaram, Vivek, and Rakesh, who are working in structural health monitoring, and our own undergraduates, as I said, Kirti and Sushmita and Narsimha, and then Prasanna, who working on heritage structures and failures, and Somshekhar, who was very innovative in working on. I think we were the only one in building one of the most largest Rama 1,000 pillar temple into numerical model. We were successful in that. And then, of course, there are many other people who have been supported. But then I would like to also try. There was never an answer by our former director and current vice chancellor in helping us in improving our research center, especially in civil engineering, combining all the fields. So with this, I would like to tell thank you all who have actually made and contributed to this presentation uh, uh, wholeheartedly. So now let me take few questions which are given in the questionnaires. Okay. Okay. Does skyscrapers enhance the earthquake activity? See, earthquake is one phenomenon. Most people believe that if there is an earthquake, if there is a short structure and tall structure, they believe that actually tall structures will get affected largely. But believe or remember one thing: earthquake is does not depend on tall structure or short structure. I mean, what I mean to say is, it does not depend on whether the structure is tall or short. It actually depends on the frequency of the ground motion, which actually matches with the frequency of the structure, which is called resonance. So tall structures need not necessarily actually enhance the seismic, it does not improve seismic activity. But the problem is, even a small vibration could cause the large deformation of the tall structures. That is why we actually take highest measurable for tall structures, so that they actually deform light. So one of the technique which is used called tune mass dampers. And there is another thing, skyscrapers, if there are large skyscrapers built on the fault lines, of course they might activate the fault lines, but there are very big structures like dam, like Koina Dam, which has actually affected the earthquake intensity. Because of the building of Koina Dam, there was an earthquake. Like it can also happen with skyscrapers. We have learned a lot of new things. Thank you so much. Why do people say civil engineering is dead? It's an interesting question. Believe me, 1999, I did join Usmania University, and then when I joined Usmania University, I also wanted to be a computer science engineer. But when I took civil engineer, of course, nothing. I just did engineering. But then when I did my PhD, and now when I'm doing research, I feel civil engineering is one of the most beautiful field. But there are certain things which have been overlooked. For example, why civil engineering? Is one of the thing is poor practices is making little effective of civil engineering. But otherwise, my own friend who is working in America is drawing a package of 60 or 70 lakhs. People feel the salaries are really less and contribution is very less in the civil engineering field. But there's a huge contribution we can really do in civil engineering. And of course packages can go to a height of almost crores per annum. One of the engineer, my friend, is drawing 5 lakhs per month as a bridge engineer with around 15 years of experience. That's what. Yes, civil engineering is not dead really. It looks like that, but there are passionate engineers who are maybe a volume might be little less, but there are passionate engineers who are working it. And now civil engineering is again is taking a revolution into new engineering, but I'm sure it's going to rise. Sir, what about actual science? Actual science, is it available in Mahindra University? I did not get this question. Actual science. See, we have the science background. As I said, sciences like Professor Pral and then mathematics professor, that all like chemistry, Chitra. There are a lot of good sciences in Mahindra because Ecole Centrale, it believes that science and mathematics are the foremost pillars of engineering, and we also believe that. And the addition of science and mathematics have been made engineering stronger. Especially, I said, structural health monitoring. I mean, self-healing concrete was actually a byproduct of civil engineering chemistry. Yes, that is there. Are civil engineers underpaid? This is, I'll tell you, when compared to the computer science engineers, yes, I say at the starting and the beginning, yes, it looks like that. But down the line, around 5 to 8 years, things are going to change. They are not underpaid, but actually the salaries are very, very high, which is not being seen, which are not being seen in the society. This is because most of the colleges are actually rated because of the immediate jobs, and accidentally civil engineers for the first jobs they pay around 4 or 5 lakhs to 6 lakhs. But very good companies are also paying, international companies are also paying very good salaries. But at the beginning, yes, it is comparatively less than other engineering fields, because you have to understand, writing a code is so different from building a structure. Building a structure is going to take 6 months to a year of time. With the advent of technology and new AI into civil engineering, I'm sure salaries will be as equivalent to any other engineer in the market. That will be in next couple of years soon. Sir, what is the scope and demand for civil engineering? right now, being me, I did masters in computer science and structural engineering from IIIT Hyderabad. So I know the mixture of different interdisciplinary fields into civil engineering. Right now, the scope of civil engineering is very, very good, and especially in water, structural health assessment, in heritage, in railways. What we see is there are many gaps in society where we can be actually part in filling that and contributing in the field, and demand is really very, very high. Even though, as I said at the beginning, it might not look like your salary might not look like other engineering fields, but yes, there's a huge demand in civil engineering field for sure. So if there are any other queries, you can actually post here. So anyway, we are going to have a couple of other webinars to come up as well. This webinar was largely on a broad sense. How did we actually start a journey from historical and ancient to the current engineering? And then what are the problems are we facing even though we have advent of technology, and where are we actually moving? So when we are trying to move into a new future civil engineering, we are going to have a robust solutions for all the backlogs which were there in the current society. So that's what all this webinar was about. Maybe in future we'll take up only one aspect of future civil engineering, like structural health monitoring or AI in civil engineering, or related to that. We will take up in coming sessions. So another question we have: how are the placements for civil engineering in MEC? There are many companies which, like L&T and Raheja. There are companies which are ready to, which have come into MEC Mahindra University and took students as well. They pay from around 4 lakhs to 5 lakhs, 3.6 to 6 lakhs as well. It depends on students and student interest, whether they are interested. So there was never a question about placements about civil engineering. So we do have good placements, but students are good if they are attending and they are passionate. Of course, 100% they can get placement in very good companies. So this. So okay. With this, I would like to stop here, and then if anybody would have like to have any queries related to admissions and all, you can always contact our admission team of Mahindra. They'll be very happy to help you in getting any relation between the related to admissions. So thank you once again. This webinar won't be valuable until I thank our Vice Chancellor and our Director, Professor Aj Meduri, who has always supported in whatever step we have taken forward. And Professor Pal and Professor Arya were always helpful in giving us always good suggestions and helping us to build the center. So what should be the best specialization in civil engineering if I choose civil engineering? It depends on you and the first 4 years of your undergraduate. And then based on your interest, you can get it into geotechnical or structural or water sources. But it depends on your passion in the project which you take up at undergraduate. Right now, like transportation, geotechnical, and structures and environmental are majors, and we need very good engineers in this field. Okay, so I'll stop here. I would like to, if anybody has got any doubt further, you can always mail it to this mail ID, or you can also see the faculty profiles in the website, and you can reach out any point of time, and I'll be very happy to answer your queries or return back to your questions immediately in a day or two. Thank you once again for giving me this opportunity. Special thanks to Praveen and Hemant, who has been helping me in arranging all these things and help me to in giving this webinar. Thank you once again to all. Special thanks to my whole team which is there at MEC. Thank you all. Have a good day. All the best.